YouTube channel. I've made an alarm design that I would like to share with you the tricks that I've done to make this design work. Well, what I wanted to share with you is what I've called a cuckoo designing, where you program for a particular microcontroller and then use a different microcontroller. The target microcontroller that you design for is not the one that you use. During the design, I had the PIC18F 452 with me, which I had gotten from a Victron inverter. It was a 3 kVA inverter, 24 volt inverter. And then the PIC18F 887 is actually a PIC that I bought from a supplier. Right. So I have a PIC18F 452, and the control panel design would fit in very well into the PIC18F 887, but well, it was filling up the microcontroller. And then I was trying the PIC18F 452, and then I realized that the code was too big for the microcontroller. So it was mainly because of the compiler that I was using. They are free compilers for PIC. They do work, but they don't actually they don't actually give you a compact code, so it was not fitting into the PIC18F 452. And then my design actually uses UART communication, so I would have to use the UART link between the keypad and the control panel. LDmicro build 5411 supports the PIC18F 4520 only. LDmicro 32 only supports PIC18F 4520, the 4550, and the 458. Still, there is no LDmicro for my PIC18F 452. So what I did was I actually had to write a code using LDmicro build 45411 and targeting the PIC18F 4520. Later on, take that code and burn it into the PIC18F 452. So this is where I'm going to share with you how I went around this problem. The solution is what I call the cuckoo design, where you program a code for a particular microcontroller, but using a different microcontroller, just like a bird, the cuckoo bird, which actually lays eggs into other birds' nests, and then that bird actually raises the young cuckoo, thinking that it is its own. Always a warning to the people who would be interested to do this. Normally for PIC microcontroller projects, there isn't much danger, but of course you will be using electricity, so you need to take caution there. And I expect the people who try these projects to be having prior knowledge of electronics, or someone who can help them. Right. Work area must be kept safe, and normally these projects are targeting people with 10 years and above. Right. Well, the document is now mature, and I've always been sharing it with you on many of my projects. The philosophy is we use electronic waste as much as possible, but of course where you can't get the component, you have to go buy the component. And yeah, as always, this is only for learning, and there's always better ways of doing these projects. My intention is that I share with you what I have done, and if there are better ways to do it, I would like feedback. I would be very much be interested in someone who would have done it different. Right. The required resources, of course, a programming computer, and all the tools that you need to build this project. Right. Feedback, you can actually write to me on tauraimirimi@gmail.com. Right. Thank you. Right. Okay. Right. This is the program for the keypad. Well, I'll just maybe show you that much. Okay. This is the program for the keypad. Okay. Right. This program is written using build 5411, and the target microcontroller, as you can see, is the PIC18F 4520. Right. And then what you do is you write your program. Any program that is, of course, this was just for the alarm keypad, right? And what you do is, after writing your program, you have your settings here and all that, and then you go here and then you compile for high-tech C. You compile for high-tech C. As I am just sharing with you with what I did, because I had the PIC18F 452, so I'm writing this program targeting to have the PIC18F 452 as the final microcontroller to run this program. So, and then after that, I get this compiled program, and then you make additions here. Here there will be a figure here. You write 9600, which is the baud rate, okay, for the UART link, and then that's all. And then after that, you save. That's all the additions that you make here. And after that, you go on save, and then the ladder file. What you do on the ladder file, you change here. This part here, 45, there will be 4520 here. Change it to 458. Pick 458 as your target microcontroller, and leave out everything. It's okay as is. You leave out everything. Do not change anything on the ladder file. Right. The other header file, nothing to change here. Leave it as is. There's nothing to change here. Right. And then you go. On the libraries, okay, you go to the libraries, PIC18, the user library. What I've done at the bottom here, I've changed to 458 there. I've changed to 458 here, although this part here was not working properly for me. Okay, this is just to make all input output pins digital. It didn't work for me. I'll show you what trick I did. Right, that's the user library, and then on the other, I think there's a C and an H file there. Yeah, I've changed to 458. I'm not sure whether this actually has an effect, but anyway, this is what I did. Okay, and then on the UART file, I think the first ones are C, are C files. This is what I did. Okay, no, nothing. Nothing on this one. I didn't do anything there. The UART library, I think the header file. I didn't change anything as well. Okay, so it's the user library only, the user library. And as you can see, the user library, these user libraries, they are not libraries of the LDmicro 32. What I did is, if you check the libraries for the LDmicro, the original PIC library, okay, the user library and the UART libraries, okay, they look like that, okay, right. These are the UART library. Where is the other UART library? Okay, like that, similar to the other one, but the user library, they look like this. This is different, okay. This is different from the user library that is here, okay. This is different. I'll show you quickly. User library, you'll see that one, okay. Let me show you. Where is the other one? That one. You see, there's the difference. Where did I get this? This one I got it from build 5411. So I copied the user library from build 4511 and pasted and replaced the ones from LDmicro 32 version 6 into the libraries of that. Okay, initially what you do is you unzip LDmicro 32 version 6a and you copy it, and then you create a folder, and then your project folder, you actually copy your project folder into the folder of the LDmicro, and then it will have this, like if I open here, it has all this, as you can check, compilers and libraries. They are actually the ones that are here, compilers, the output, input, and all that. So I copied my project into a folder like this one. You copy your project into a folder like this one, and then on the compiler side, I'll show you the PIC18 compilers. I'm using this one. This one you can get it on the GitHub page of LDmicro 32 by Joe Gill. Right, unzip the folder, and then you copy the compiler into the compilers folder. You edit this part here, you put your compiler. This is the where you actually edit, because the original just it has PIC18 here, and then it has got a different compiler that it is used. Okay, let me just show you. Here is the original batch file. It has this part here, so you actually copy the high-tech compiler and place it here. That's the addition, and then remember to save. Always save after addition. You save the batch file, or after every change that you make, you save the batch file. Right, so that's what you do. So you are going to use that compiler in the compilers folder to compile your project. Right, so you open the LDmicro executable file, and then this is what you get. Okay, and then here this is now the LDmicro 32. Here is the target PIC18F 458. Right, so do not compile ladder to C. You just go here and build C and for X file. Why you have to target the 458 is because, okay, before that, here, as you can see on rung number 1 here, this is what I did to actually force all the pins to become input, digital input and output. You move 7 to this special function register here. Move 7 to special function. This is adcon number 1. Actually, this is adcon number 1. Okay, right. Let me show you quickly how you do that. Why you have to do that? Okay, here it is. Right. So on this one you can see that the ADCON ADCON 1, which is a DC control 1, is special function register 1, is on address here, the FC1 address, which is this one. You move, this is how you move. 7 is coming from there. This is the 7, and if you go to the datasheet, you're actually forcing the ADCON to be all digital. This is number 7. 6 will do actually also, because it doesn't care here whether it is 0 on the X here. PIC18F is similar to PIC18F 452, and LDmicro 32 supports that. So that's why I had to select the PIC18 458. So on the UART link, the PIC18 452 is similar to PIC18F 458, and LDmicro supports PIC18F 458, as I was talking about in the first part, where I actually showed that LDmicro 32 supports this. So I target this microcontroller, but I have this microcontroller. I can't write and compile and build for this microcontroller. It will not run into that. So this is why I had to target 458, and it worked. The trick worked. This is a cuckoo method to actually build a code for a different microcontroller. And on the compilers, only this one was working for the PIC18F 452. I tried the XC8, the version 134, the version 136, and the version 141. They were not working. Right, so this part was supposed to do this part here. I'm saying, okay, this to actually make the microcontroller pins all digital. So that was not happening. The key points is, right, you write your program in a LDmicro build LDmicro build 5411. You compile for high-tech C, and then you leave out, and then you go to your project folder, you edit your you go to your project folder, you edit your C, you also edit your ladder, and then you copy libraries from build 11 like this. You go and do this. You go build 11 5411, that is, you go to the libraries, and then you go PIC18, right, and then you copy the user library, these two, one is H, the other one is a C, and then you paste into there. So you are replacing the original user library of the LDmicro 32 by that one of build 5411. Okay, and then after that you edit the user library. Okay, you edit the user library, the user lib, you put 458 here, and then I'm not sure whether that change is doing anything. There is a lot of try and error that you can do, and yeah, it takes time, but after that it worked for me. This is how you actually cuckoo the program. So I've made a summary of it here. Okay, you how to cook with the PIC452, right. You actually write a program for 4520, and then you make these adjustments, and then you go on the UART, you adjust it to 9600 about, and then you change the peak target. And then after changing the peak target, here you have to actually change also there, but that wasn't working, so I had to actually make a force load into the special function register of 7, and it only does it once. Once the program starts, it only does once. I can show you because of that. This is a one shot, so it only loads once on the start of the program. This is the part I was talking about. You move for 7 into the ADCON 1 register. Right, okay. You just go and build for a hex solution. Do not compile in LDmicro 32. I tried to compile in LDmicro 32. The compiler do not understand the C. There's a lot of adjustment that you have to make. So I just avoided it and just compile using build 5411, and then I go to LDmicro 32, make a target for 58, and then build X for that, and that's all, and it's running. Right, okay, so thank you. Think that's all. So remember, please, any comments, any feedback? Thank you. Okay, this is the keypad that I have done with a PIC18F 452, and it's showing those 5 zones as open, and it's just free running. Okay, and at the bottom there, those red buttons are for the code entry and programming.